Thanks to the auditorium for putting questions. And we move on to the next presentation. The next presentation is from Raji Marya from Morocco. And the presentation brings us into the packaging sector and cellulose for paper and pulp-based packaging from, of course, pulp residues.
Thank you. Thank you for this introduction, and many thanks to the audience for being here today and attending my presentation, which intitulated Recovery of Cellulose Fiber from that Palm Front for Pulp and Paper Making Applied in Active Food Packaging. I will try to use that. It's okay. So, as you know, our forest, which acts as like earth lens, is disappearing very fast because we use paper. Sorry, because I want to speak in French. So we use paper in a huge amount, around 405 million tons. And on another side, we have palm waste in huge amounts and huge quantity in different form, like branch, frond, or leaves, etc. So, based on the result, we must moving away from relying to the tree for producing paper by using palm biomass as like palm waste or exactly palm leaves. Because we know that is by using palm waste, we are not just ease the pressure on the tree, but also we create eco-friendly products and sustainable paper. So by using this option, we are not just help our environment, but this is a moral duty for our generation, for the generation that come after us. So let's focus on the paperboard. So paperboard is very interesting in packaging for different industries, and it's exactly it's teeny and stronger than that regular paper, and. Thinking about what is active paperboard. So active paperboard is it goes a step further by using technologies and materials in order to get better properties and high characteristic of paperboards exactly. So. Let's explore technologies to make active paperboard. We can take nanotechnologies. So by using nanotechnology, we can produce more efficient and sustainable active paperboard. And we can, given a definition of nanotechnology, which is all about using materials at incredibly tiny scale, exactly nano size, and it helps us to give to amazing control of how the material behave. Okay. So. By using nanotechnology, we can produce, we can made a mixing or combination of materials in order to enhance mechanical properties, thermal properties, etc. But thinking about if we have nanoparticles like nano clay, nano cellulose, graphene nanosheet, etc., we can improve, boost the mechanical properties, and also we can get high barrier and good protection in our active paperboard, and also we can preserve the food inside of the packaging and enhance the shelf life of our product. So we can think about lignin, nanotechnology-based lignin as a bioproduct of paper making. Lignin is abundant and renewable materials, and it can break down via advanced processing to produce nanoparticles. It's in the same time sustainable and is a bioproduct, as I said, and the beauty of lignin is not just improving properties. We can say it, we can talk about barrier properties, antioxidant activity, antibacterial activity, UV shielding, but also it improves the recyclability of our material. The objective and the originality of my work is to valorize the date palm leaves to produce pulp, and then the use of lignin nanoparticles from argan nutshell as a biomass to produce active paperboard with enhanced mechanical, structural, antioxidant, UV shielding properties, etc. Here we have the material that we have used. So we have used date palm leaves and argan nutshells for producing nanoparticles, and the ketosene as just matrix for coating. Here we have the process of production. The pulping process. In the pulping process, we have 4 steps. The first one is the preparation, in which we grind the fibers of the leaves, and then we have cooking, and after washing, we have a bleaching process to get cellulose fibers. In the next part, or in the last area, we have a machine for producing paper at a laboratory scale, in which there is also 4 steps: dispersion, and then dehydration. We have water squeezing and the drying. And on another side, we have the process, a brief schematic presentation of the lignin nanoparticle process from argan nutshell, and the coating process via spray coating, via ketosene, by using ketosene matrices. Okay, here we have some results. We will start by chemical composition, and here we have the FTIR curves of around that palms, and bleached one, and the final active paperboard. We can conclude that we have successfully separated the cellulose fiber from confirmed by the disappearance of the band of impurities like lignin and hemicellulose. On the other side, we have the chemical composition of our materials, which confirm the reach of our material by lignin and cellulose fibers, cellulose compound. Here we have optical microscopy images, which confirm that we have a successful defibrillation of cellulose fiber to the 1.1 millimeter in the length and 70 micrometer in the diameter. This result is close to that of wood cellulose fibers used for paper making. Here we have the CM image and STEM images of lignin, alkali lignin, and then for lignin nanoparticles, which confirm that we have produced the lignin nanoparticles with the spherical shape and around of 55 nanometer in the size. And the 2 pictures we have a comparison in between coated and non-coated paper, so we can confirm that it's difficult, but we have, because I have the same image, sorry to not integrate it here, but it's clear on the same image that we have an entanglement of fibers, and also we have a good coating of the paper board produced. So here we have the curve of UV analysis, which confirms that there is an absorption of non-visible light by lignin nanoparticles and by the film used in the coating, which confirm that we have UV shielding properties of our producing packaging, which are good properties for protecting the chemical compound of our product and to not get enzymatic browning or oxidation of the compound inside of the food inside of packaging. And the other side, we have the antioxidant activities of the ketosane and of the film with the nanoparticles of lignin, which confirm that we have a good antioxidant properties around with other nanoparticles is around of 48%. That is good for our active paperboard. So here we can talk about antimicrobial properties of lignin, and all researchers talk about the antimicrobial properties of lignin. The reality is, as we say here, that we have a bacteria, some lignin nanoparticles coated by the bacteria coated by the lignin nanoparticles, which confirm it, and then antibacterial properties by this transparency area under the film. Here we can conclude that we have an adsorption or the coating of the lignin nanoparticles of the microbia by the lignin nanoparticles, and the inhibition of the bacteria, which is good for our food to improve the shelf life and the quality of our food. But it's not enough, because we don't have a huge area around of the film. But we can improve the antibacterial properties of the lignin by modifying the shape and introducing some metals like zinc oxide, or there is many sulfur nanoparticles. There are many types of nanoparticles. And finally, as we have an increase in mechanical properties, exactly in Young's modulus, which confirmed by the rigid characteristic of lignin nanoparticles, and the value of Young's modulus is very close to that of commercial paper, which have produced by wood cellulose. So we can confirm from the results that that palm fibers is a good candidate for producing active paperboard. Finally, we can conclude that palm fibers is good, exactly leaves is good candidate for producing active paperboard by incorporating lignin nanoparticles as a reinforcement or not as a reinforcement of coating, and also we get good antioxidant properties, anti-UV properties, good mechanical properties, and antibacterial properties. And thank you for your attention.
Thank you very much, Raji. I like this term, active paperboard.
Thank you, thank you.
And the lignin in this active paperboard. I've studied wood chemistry 50 years ago, but I've never heard this term, so I like this very much. And this is what I said earlier this morning. We have to sell an extra with the product.
Thank you. Thank you.
And this is this active paperboard. To me, it's one of the fascinating words in the market. But You have the floor, ladies and gentlemen. You can ask questions to Raja. Are there questions? Yeah, yes, please. Two, one more.
Thank you for this nice presentation. In fact, you know, food packaging industry is very big, and it is a good idea also to incorporate nanostructures to enhance certain properties, antimicrobial, mechanical, and so on. But what about the concentration? Have you tried to optimize the concentration of these nanomaterials in the host? Because if they exceed certain limit, you know, they can contribute negatively. They can reduce the mechanical properties. Second question, have you tested the degradation under some harsh condition like heat or something like that?
Thank you for the question, but the concentration, normally for nanocomposites we must we must use at a maximum 5 weight fraction percent. But in this case, because we are we have the I have the I was thinking about getting more UV properties and getting good properties in terms of UV antioxidant properties. I have used 20 weight fraction percent of the lignin nanoparticles. And there is we have because normally I work on smart materials, and exactly by using nano molecules, nanoparticles. So I know that is we must stop on 5 weight fraction percent. For the second questions, we work on producing lignin nanoparticles, but it was the occasion to testing this new material in palm paper board. That's why I don't make the other characterization, but maybe for next work.
Thank you. The other question? Who? Where was the other question, or second one? No, no more? We have still questions. Of course, you can use the lunch break as well to discuss. So if not, I take the opportunity to give you the certificate appreciation for the presentation.
Thank you.
Thank you very much.
So I want to provide this occasion to thank Professor Qais Abou Qasim. It's my professor in my life, and also in my all precursor during my sorry, because I'm with Professor Qais from master degree thesis, postdoc researcher, and now I'm researcher supervisor under the supervision of Professor Qais Abou Qasim. Thank you for all you.
Thank you.